Every 24 hours, Earth completes one full rotation on its axis. That's why we have day and night. Every other planet spins too. So do stars, asteroids, black hole, and even entire galaxies. But why does almost everything in the universe rotate? To answer that, we have to go back to how these objects are born. Every planet and every star begins as a vast cloud of gas and dust drifting through space. At first glance, a cloud like that looks completely still, but it isn't. Different parts of the cloud are slowly moving in different directions. The motion is so tiny that you wouldn't notice it, but it's there. So where does that tiny motion come from? The early universe was never perfectly smooth. Some regions were slightly denser than others, and matter moved in tiny random directions. As gravity pulled material together, it didn't arrive from every direction equally. Some gas approached a little faster. Some came from a slightly different angle. Imagine rain falling into a bucket. If every drop landed perfectly in the center, the bucket would never turn. But if just a few more drops hit one side than the other, the bucket begins to rotate. A forming cloud works the same way. Gas doesn't fall perfectly toward the center. It falls slightly off-center, giving the cloud a tiny amount of rotation. At first, the spin is almost impossible to notice. Then the universe gives it a few more pushes. Nearby, stars and galaxies pull on the cloud with their gravity. Shockwaves from exploding stars pass through it. Sometimes other clouds bump into it. Each of these gives the cloud a tiny push. So by the time gravity pulls the cloud inward, it's already spinning a little. Eventually, gravity takes over. Gravity is the attraction between masses. In Einstein's theory of general relativity, you can picture it as mass-bending space-time graph. The larger the cloud becomes, the deeper that bend, and the more strongly matter falls inward. But because the cloud is already rotating, even by the tiniest amount, the gas doesn't fall straight to the center. It spirals inward. And that's where the real story begins. As the cloud collapses, it becomes smaller. And when a rotating object shrinks, it spins faster. This is called the conservation of angular momentum. Angular momentum is the amount of rotational motion an object has. Unless something outside interferes, that amount stays the same. Imagine sitting on a spinning office chair with your arms stretched out. Someone gives you a gentle push. Now pull your arms close to your body. You immediately spin faster. No one pushed you again. Your rotation sped up simply because the same angular momentum was squeezed into a smaller space. A collapsing cloud behaves exactly the same way. As it shrinks from a cloud, spanning trillions of kilometers into a newborn star, its slow rotation speeds up dramatically. The faster it spins, the harder it becomes for material to fall in along the sides. Instead, the cloud flattens into a rotating disk. Most of the material collects at the center where a young star is born. The rest remains in the disk. Tiny grains of dust collide and stick together. Those grains become pebbles. Pebbles become rocks. Rocks become planets. And because every piece formed inside a disk that was already rotating, the planets inherit that rotation from the moment they're born. But that raises another question. If you spin a toy on Earth, it eventually slows down and stops. So why doesn't Earth? Because on Earth, spinning objects lose energy to air resistance and friction. Those forces constantly work against motion. Space is different. It's almost completely empty. There is essentially no air to push against a planet and almost nothing to steal its rotational energy. Once a planet starts spinning, there's very little to slow it down. Earth has been spinning for about 4.5 billion years, and it would have continued spinning at nearly the same rate if it weren't for the moon. The moon's gravity gradually slows Earth's rotation through tidal forces, but the effect is incredibly small. The same idea appears everywhere in the universe. When a massive star reaches the end of its life, its core collapses. Any tiny rotation it already had is compressed into a much smaller object, producing neutron stars and black holes that can spin hundreds or even thousands of times every second. Galaxies form the same way. Enormous clouds of gas collapse under gravity, their slow initial rotation speeds up, and the whole system settles into the vast rotating disk we observe across the universe.